The processing practices associated with the slaughter of cattle have long been improved and advanced to improve both the animals' till-death welfare and food safety standards for consumption by both humans and animals. One of the key concerns has been Escherichia coli, or E. coli, contamination of the meat. This is attributed to the fluids from the digestive system of cattle contaminating the meat whilst undergoing post-slaughter practices. Ongoing research is now showing a correlation between grain feeding of cattle and increased E. coli levels in their digestive system. The E. coli provide the function of breaking down the starch in the grain, and therefore levels are increased in cattle that have a higher proportion of grain in their diets. The scientific journal article, Grain Feeding and the Dissemination of Acid-Resistant Escherichia coli from Cattle, investigates the role of E. coli in the digestive system and its proportional levels associated with the category and quality of nutrition received by the livestock. The aims of the study were to explain the increased incidence of foodborne illness, to improve food safety, and continue to maintain the higher industry food safety standards for meat production in developed countries, to investigate the suspected more rapid evolution of bacterial virulence factors, to maintain and improve the food hygiene and work out strategies to best overcome and minimise the impacts of the bacterium, to investigate the role of acid resistance in the dissemination of pathogenic bacteria. The purpose of this was to determine the link or correlation between the type of feed cattle were fed and the number of bacterium in their digestive tract that could potentially impact the meat through carcass contamination. To determine the impact of these aims, the following method was used. Colonic digesta were removed from the rectum of cattle that had been fed hay, grass, and varying amounts of rolled corn. The pH of the digester was tested by a combination electrode. This was followed by a measure of turbidity to determine the level of coliforms in the sample that could potentially pose threats to the health of humans and health safety standards to be accepted into the retail sector. The bacterium were also tested for acid shock with lauryl sulfate broth to determine the alkalinity of the colonic bacterium and their ability to survive a change of diet. For example, from a grain-based diet to a pasture-based diet. The study was conducted with a herd of mature, non-lactating Holstein cows that were fed every 2 hours in diets of 0, 45% and 90% grain. The results of the experiment demonstrated that grain supplementation had a small effect on the numbers of anaerobic bacteria in the rumen, but in the colon there was a 1,000-fold increase. Strains of bacteria were very similar between each feeding regime, but the grain-fed bacteria had more acid shock survival. The findings could potentially have massive impacts on food safety, as this could lead to greater harbouring of pathogenic strains and potentially increased dissemination of E. coli from cattle to humans. Grain feeding has long been used to improve the productivity and efficiency of the cattle industry. This report demonstrates the impact of grain feeding on the virulence and numbers of E. coli in the digestive system of cattle that could potentially spoil the meat. The recommendation of the author was a brief period on hay before slaughter to reduce the risk of foodborne E. coli.